Hello students, welcome to Target IES. In this video we are going to continue with our third module on determinacy and indeterminacy. This module will be very small because we will be studying only frames. In the next module we will study trusses and then we will study hybrid structures. Fine. So in the last module you have seen the beams, right? It was very simple because our static indeterminacy ds is equals to dsc, which is external indeterminacy, plus dsi, which is internal indeterminacy. What was dsi for beams? It was always equals to 0, right? So your ds, static indeterminacy, was nothing but your external indeterminacy. Fine. So, and what is the equation for your external indeterminacy? Very simple, r minus s, number of reactions minus number of equilibrium equations. We have to be careful with number of equilibrium equations, right? It is not always equals to 3. Depending on the loading, for the flat structures, your s value will change. I hope you are perfect in s values, right, from the last module. So I am confident that you are perfect in it. Now let us continue with frames. In frames now, you don't have any such twist. It is very simple. Your s value is always equals to 3. Why? This is not a flat structure, right? So this is not a flat structure like say fixed beam or a continuous beam. So this always will have equilibrium equations as 3. Fine. So there is nothing much here. R minus s is your external indeterminacy, but extra thing which you have to be careful is your internal indeterminacy. First let us see external indeterminacy and then we will see internal indeterminacy. Fine. So let us take a frame like this. One end it is fixed and other end it is pin jointed. Can you tell what is the external indeterminacy? How many reactions are there at the fixed end? Basically we will have 3 reactions. One vertical reaction, one horizontal, and third one is moment. So number of reactions are equals to 3. Here I have a pin joint. I have a vertical reaction, I have a horizontal reaction, but there is no moment here, right? So number of reactions is 2. So total number of reactions I have is 3 plus 2, which is 5. And number of equilibrium equations I have is 3. Therefore my DSC is 5 minus 3, which is equals to 2. Therefore this structure is externally indeterminate, right? If your DSC value is 0, then it is externally determinate. Fine. It is greater than 0, therefore it is externally indeterminate. Simple, right? Now let us see 2 more examples like that and then we will jump into internal indeterminacy. काफी important रहेगा, ठीक है? So from here the question comes mainly. Fine. So now can you tell what is externally indeterminacy of this simple structure? One end pin, other end roller, right? So can you tell it? Here I have 2 reactions, vertical and horizontal. Will there be moment here? No, right? There won't be any moment because it is a pin joint. Here I have a roller support. In roller support I have only vertical reaction. It is free to move in horizontal direction and it is free to rotate. There is no moment of resistance. So I have only one reaction here. So my R is 2 plus 1, which is 3. Fine. My number of equilibrium equations are 3. Therefore my DSC value is R minus S, which is 3 minus 3 is equals to 0. If DSC is 0, then what should we call? We should call this structure as externally determinate structure. Simple है ना? Now let us see a complicated structure. एग्जाम में ना ऐसे नहीं पूछेंगे. So this is only for your knowledge. एग्जाम में कुछ इस तरह से पूछेंगे, ठीक है? So you will be given a big structure and he will ask you to find static determinacy. Okay, static indeterminacy. You should find both external and internal indeterminacies. Fine. So can you find external indeterminacy for this structure first? Simple hai. Just count number of reactions are there and minus your equilibrium equations. Fine. So how many reactions are there? This is a fixed end, so we have 3 reactions. This is a hinge end, therefore we have 2 reactions. What are they? One is vertical and second is horizontal. There won't be any moment. Here I have a pin joint, again very similar to this. I have 2 reactions. There won't be any moment. Right, here I have a roller support. Roller support will have only one reaction, vertical reaction. So I have only one reaction. Here, what is this structure? Do you remember? In the last module you have studied type of joints, right? This is a this is the guided support, right? So in guided support, what it will do? It can take vertical reaction and it will also have moment of resistance, but it is free to move in horizontal directions, right? So this is about guided support. So in guided support we have 2 reactions, one is vertical and other is moment. And this is the axial spring. Axial spring, it takes only axial force. So obviously there will be only one reaction, vertical in this direction, right? So I have only one reaction at this end. So number of reactions which are there in this structure are 3 plus 2 plus 2 plus 1 plus 2 plus 1. So how many are there? 5, 6, 7, 8, 9, 10, 11. So R is equals to 11. And number of equilibrium equations, I have 3. Therefore my DSE is R minus S. 11 minus 3 is equals to 8. Obviously it is externally indeterminate structure. Simple. Done. Now very important concept. Let us enter internal indeterminacy for frames. Okay, only for frames. Okay, then we will study for trusses. Now it is only for frames. I have a simple formula to find internal indeterminacy. What is that formula? The formula is 3 into C. Okay, for all plane frames we just have to use this simple formula for our static internal indeterminacy. What is that? 3 into C. What is C? C is number of closed boxes. एक क्लोज्ड बॉक्सेस क्या है, डायग्राम से मैं समझा दूंगा, ठीक है. सो यू कैन सी हियर योर DSI फॉर्मूला इज 3C फॉर प्लेन फ्रेम्स एंड 6C फॉर स्पेस फ्रेम्स. ये ऑब्जेक्टिव के लिए पढ़ा रहा हूँ कि 6C. ओके, इन एंटायर स्ट्रक्चरल एनालिसिस देर इज नॉट इवन अ सिंगल क्वेश्चन विच विल बी सॉल्विंग रिलेटेड टू स्पेस फ्रेम. वी विल बी सॉल्विंग ओनली क्वेश्चन रिलेटेड टू प्लेन फ्रेम, ठीक है. सो ओनली फॉर ऑब्जेक्टिव पर्पज मैंने बता दिया कि इंटरनल इंडिटर्मिनेसी इन केस ऑफ स्पेस फ्रेम इज 6C. But it is not for problems, only for theory. Fine. So what formula which we use? We use 3C for plane frames. And what is the C value? C is number of closed boxes. If you see this structure, okay, so how many closed boxes you can see? You can see one closed box, this one, right? This is not a closed box because it is open. Okay, so I have only one closed box in this structure. So how many C's are there? There is one C. Fine. C value is equals to 1. Now can you tell me what is C value in this structure? ये तो ओपन है, कोई क्लोज्ड स्ट्रक्चर है ही नहीं है इसमें, तो सी वैल्यू क्या हो जाएगा? 0 हो जाएगा. सिंपल है ना. सो व्हाट इज योर सी? सी इज नंबर ऑफ कट्स रिक्वायर्ड टू ओपन अ क्लोज्ड कॉन्फ़िगरेशन और नंबर ऑफ क्लोज्ड बॉक्स. ये पूरा याद रखने की जरूरत नहीं है, आप सिंपल से याद रख लेना नंबर ऑफ क्लोज्ड बॉक्स. सो व्हाट इज योर स्टैटिक इंडिटर्मिनेसी? Sorry, what is your internal indeterminacy? It is 3C. Now can you tell me for this structure what is your internal indeterminacy? 3 into C. 3C is 0 because there is no closed box. So 3 into 0 is 0. Therefore this structure जो है ना ये fixed at both ends and nothing inside. So this is internally determinate structure. Simple. Now can you tell me what is internal indeterminacy for this structure? देख के बता सकते हो. What is C? C value is 1. If C value is 1, your DSI is nothing but 3 into C, which is 3 into 1 is equals to 3. Therefore, it is internally indeterminate structure. Simple. Done, right? So, can you tell me what is DSE in this case? DSE. I am talking about external indeterminacy. So, DSE was R. यहाँ पे 3 रहेगा, यहाँ पे 3 रहेगा. So, my R is 3 plus 3, which is 6. And number of equilibrium equations are 3. So 6 minus 3 is equals to 3. Okay, your DSI is 0, DSE is 3. So what is your DS? DS value is DSC plus DSI, which is 3 plus 0 is equals to 3. So your answer will be 3. Simple. So in this case, what is your DSE? Same na, here it is fixed, here it is fixed. Number of reactions 3 plus 3 6. So your DSE value, DSE is equals to 3 plus 3 6 minus number of equilibrium equations 3. 6 minus 3 क्या हो जाएगा? 3 हो जाएगा. So what is your DS value in this diagram? For this diagram your DS value is DSC plus DSI. 3 plus 3 which is 6. Simple. Done. Easy है ना. Now let us see a big problem. ये तो था theory. Now you should be able to solve this question. Let's do the question very fastly. Now let us find DSE first. External indeterminacy DSE. क्या है DSE formula? R minus S. So how many reactions are there? Here it is a fixed end, fixed end, fixed end, fixed end. Therefore 3 reactions, 3 reactions, 3 reactions, 3 reactions. 3 into 4 is equals to 12. How many equilibrium equations are there? 3. So my DSE value is 9. No issues, right? Now let us find DSI. What is DSI? 3 into C. So how many C's are there? C means number of closed boxes. I have 1 closed box, 2 closed box, 3 closed box, 4, 5 and 6. Okay, the closed box can be of any shape. ओके ऐसा नहीं है कि स्क्वायर ही रहना चाहिए, रेक्टेंगल ही रहना चाहिए. इट कैन बी ऑफ एनी शेप. ट्रायंगल भी रह सकता है, ट्रेपेजॉइड भी रह सकता है, पेंटागन भी रह सकता है. इट डजंट मैटर. इफ यू फाइंड अ क्लोज्ड बॉडी यू शुड काउंट इट एज 1. Fine. So there are 6 C's in this diagram. Therefore, what will be my internal indeterminacy? 3 into C, which is 3 into 6 is equals to 18. So what is my ds? Ds value is nothing but dsc plus dsi. So 9 plus 18 is equals to 27. That is your static indeterminacy. सिंपल. वही यहाँ पे लिखा है क्लियर से, लिखने की कोई ज़रूरत नहीं है. इफ़ यू आर टेकिंग दिस कोर्स ऑब्वियसली ये हार्ड कॉपी आपको आ जाएगा. सो इफ़ यू हैव दिस हार्ड कॉपी राइट, your preparation 50% is done. Remaining 50%, if you listen to me, it will be finished. Okay, you will be able to solve each and every question related to ESC and GATE. Okay, that's my promise. At the end of this chapter आप ही समझ जाओगे. ठीक है, you can open any of the ESC and GATE question, you will be able to solve that. Fine, that is my promise. C is equals to 6. What is your DSI? 3 into 6. 3 into C है ना, इसलिए 3 into 6 18. And your DSC is R minus S. Number of reactions we found it as 12. 12 minus 3 is equals to 9. Okay, 18 plus 9 is equals to 27. Fine, simple. We have got this right. इसे भी एक शॉर्टकट बता दूँ. This is a two-step process. Actually in GATE and ESC ना, he never asked what is your internal indeterminacy or external indeterminacy. He simply asks what is your DS value, static indeterminacy. Okay, so to get static indeterminacy, this is a two-step process. हमने क्या किया है? First we have found DSC. My first step was to find DSC external indeterminacy, and my second step was to find DSI internal indeterminacy, and then third step was adding these two to get my static indeterminacy. 3-step process है. Simple process ही है, but this is a 3-step and it can take you around 1 minute, right? I have another shortcut. In this shortcut you can solve this question in 30 seconds. ओके, देखना चाहते हो शॉर्टकट क्या है? इन दिस ना वी आर नॉट कैलकुलेटिंग DSC DSI, वी विल बी डायरेक्टली कैलकुलेटिंग और DS, वी विल बी डायरेक्टली कैलकुलेटिंग और स्टैटिक इनडिटर्मिनेसी. फाइन. सो व्हाट इज द मेथड? पहले फॉर्मूला आप याद रख लेना, देन आई विल एक्सप्लेन व्हाट इज दिस फॉर्मूला. फाइन. सो योर DS is equals to 3C dash minus number of reactions unnecessarily added to make stable cantilever. फॉर्मूला देख के डर मत जाना, मैं सिखा दूंगा. इट इज़ अ वेरी सिंपल फॉर्मूला. 3C dash minus number of reactions unnecessarily added to make stable cantilever. What it is, I will explain you. So here what we are doing is, just a second, और यहाँ पे डाल दूंगा मैं सेम स्ट्रक्चर, नो इश्यूज. जस्ट गिव मी ए सेकेंड, काफ़ी इंटरेस्टिंग रहेगा, सो कीप लिसनिंग. So this was my structure, right? So what I am doing is, now my DS formula directly, you have already seen one method. This is the second method. So in this method you can get your answers directly. Fine. यहाँ पे DS का फॉर्मूला क्या है? 3C dash minus number of reactions unnecessarily added to make stable cantilever. I will explain you each and every term. So number of cuts you require. C dash का ये मतलब है number of cuts you require to make it stable cantilever. So what you are doing? You are cutting the structure. When you are cutting the structure, you should get stable cantilevers. If you are cutting like this, you can see this is a cantilever, right? इस तरह से देख लेना, आपको आदत है ना बीम्स इस तरह से horizontal देखने की. So this is a cantilever. One end it is fixed and other end it is free. There is no reactions here. Okay, if you are cutting like this, there won't be any reactions at this side. Okay, there won't be any supports here, so it is a cantilever. Fine. So similarly, if I am cutting here, I will be getting the middle part as a stable cantilever. You can see, right? It has one end fixed and other end we don't have any supports. Fine. And similarly, if you cut here, you will be getting two stable cantilevers. You can see this is one stable cantilever and last part, ये जो part है ना, this is one stable cantilever, right? Simple है ना? So 3C dash minus n number of reactions unnecessarily added. इसका मतलब है, for example, if there was pin support instead of a fixed support, तो क्या हो जाएगा? This can't be a cantilever, right? See, you have cut the frames. Now this is not a cantilever because it is free to move. तो हम क्या कर रहे हैं? first we are making the pin support as a fixed support. In case if there was a pin support, what you have to do, you have to make a fixed support. So what you are doing, you are adding one more reaction. पहले moment नहीं था, now we are adding that moment, right? So your moment is your extra reaction which you have added to make your pin joint as a fixed joint, right? वो reaction जो आप unnecessarily add कर रहे हो to make it a stable cantilever, वो यहाँ पे subtract करना है. You will be getting direct answer. काफ़ी simple है. Don't worry. Don't think this method is big. If you do 2 examples now, you will solve this question within 30 seconds. Okay. Now let us solve this question first of all. All ends are fixed. Calculate what is your ds directly. Okay, so how many cuts you have to make? 1 2 3 4 5 6 7 8 9. So how many cuts you are making? You are making 9 cuts to make it into 4 stable cantilevers. एक कैंटिलीवर हो जाएगा, उसके बाद एक कैंटिलीवर हो जाएगा, एक स्टेबल कैंटिलीवर हो जाएगा एंड ए पार्ट दूसरा स्टेबल कैंटिलीवर हो जाएगा. सो 4 स्टेबल कैंटिलीवर्स बन जाएंगे. ठीक है. सो हाउ मेनी कट्स यू मेड? यू मेड 9 कट्स, राइट? सो व्हाट इज योर ds? 3 c dash minus n. 3 into 9 minus n. Number of equations unnecessarily added to make it stable cantilever. Here all were already fixed, so you didn't added any reactions. So what is your n value? N value is 0. So what is your ds? 3 into 9 minus 0. So 3 into 9 is 27. Okay, directly 27 आ गया. In the previous case, what we have done? We have calculated DSI individually, we have calculated DSC individually, and then we have added to get 27. Up to you. ये भी कर लेना, 1 minute में आ जाएगा. But if you use this method, you will get answer within 30 seconds. Okay, so let us solve some questions related to this formula and then you will be perfect in it. Fine. Can you solve this question? हम इस क्वेश्चन दोनों मेथड्स में करेंगे. ठीक है. फर्स्ट विल डू इन फर्स्ट मेथड. सो व्हाट इज द क्वेश्चन? आई हैव अ स्ट्रक्चर समथिंग लाइक दिस. I have a guided roller support. Yeah. Okay, so I am doing this in the first method first of all. So first method में क्या किया था हमने? We have founded DSC first. What is DSC here? Can you tell me very quickly? How many reactions are there? There are 3 reactions. Here it is a pin joint, so 2 reaction. Here it is a guided roller, so 2 reactions. So number of reactions I had was 3 plus 2 plus 2, which is 7. उतना है ना? Minus number of equilibrium equations 3. So I used to get 4 as my external indeterminacy. So what was my DSI? Internal indeterminacy. Formula काफ़ी simple था, 3 into c. So how many closed boxes are there? 1 2. Okay, so what is your c value? C value is 2. 3 into 2 is 6. So what is your ds? Ds is 4 plus 6 is equals to 10. सिंपल है. दिस वॉज मेथड नंबर 1. नाउ आई एम गिविंग यू मेथड नंबर 2. आपको जो मेथड ईजी दिखा ना वही मेथड एग्जाम में आप यूज़ कर लेना. आई विल यूज़ मेथड नंबर 2. ओके, नाउ आई एम लीविंग इट टू यू. इन द सेकेंड मेथड व्हाट इज माई फॉर्मूला? ds is directly equals to 3c dash minus n. Okay, so in second method what is c dash? Number of cuts you need to make it stable cantilever, right? 1 2 3 4. कितना है सी डैश वैल्यू? सी डैश वैल्यू 4 है, राइट? 3 into 4 minus n. You can see this end is fixed, so you need not add any reaction. But here it is a pin joint. So how many reactions you have to add to make it a fixed joint? You have to add 1 reaction, right? You have to add 1 moment extra. So here you have to add 1 extra reaction, which is 1, right? Here it is a guided roller. It already has 2 reactions, but it is free to move in horizontal direction. So you are adding horizontal reaction extra to make it similar to that of fixed beam. So here also I am adding 1 reaction extra. So how many reactions we have added extra? 2 reactions, right? So that 2 reaction I have to subtract. My n value is 2. So 3 into 4, 12 minus 2 is equals to 10. आंसर दो भी सेम है. यहाँ पे आपको आ जाएगा सिर्फ 2 लाइन में, यहाँ पे आपको करना पड़ेगा 5-6 लाइन. इट इज़ अप टू यू. आई यूज़ दिस मेथड. काफ़ी सिंपल है, ऐसे ही आंसर आ जाएगा. नाउ लेट अस सी अ गेट क्वेश्चन विच वाज आस्क्ड इन 2004. या यू कैन सी दिस क्वेश्चन. which was asked in 2004. Here he was asked, this question was given for 2 marks, and he was asked to find ds and dk. Dk yani kinetic indeterminacy. We will solve after 5th or 6th module. For now let us solve ds. Okay, can you tell me answer for this question? So my ds value is, what is the formula? 3c dash minus n na. So how many cuts you have to make? 1 2 3 4. आपने 4 कट कर दिया, सबको डिवाइड कर दिया है. You have made individual stable cantilevers. Perfect. Okay, how many reactions have you added? 3 into 4 minus. How many reactions are you adding? Here you didn't add any reaction. Here you have to add one reaction because it is a pin joint, right? So you have to add moment extra to make it as a fixed beam, right? So how many reactions are you adding here? You are adding one reaction here. And it is a roller support, right? It has only one reaction. So you have to add two reactions. You have to add horizontal reaction and also moment. If you add two reactions, then it will act similar to that of fixed beam, right? To make it as a stable cantilever, you have to add two reactions here, right? So your n value is 1 plus 2, 3. So 3 into 4 is 12 minus 3 is 9. Okay, your ds value is 9. So you can say your option will be in one of the C and D. Okay, remaining question आप solve कर पाओगे after having the knowledge of kinetic indeterminacy which you will be getting in the module number 6 or 7. Fine, इतना ही होता है. I assure you at the end of my modules you will be able to solve all the GATE and GSC equations. That's my promise. Okay, if you see this question, GATE 1993 wala, this is related to hybrid structures. This is also frames, but what is extra? If you see properly, आपको दे दिया जाएगा एक internal hinge और he will give you horizontal shear release. Okay, these type of things we will discuss in detail. ठीक है, after 5th module ना, you will be able to do these type of questions also. Fine, these type of questions, very easy. Okay, don't worry, you will be perfect in this chapter. Fine, see you in the next module.